you will be rigging this squid guy right here. I need some sort of cool, snappy name for him because I really have no idea what a squid with 2 arms would be called. Well, squid. Okay, we'll just go with Squidward. That's fine. Now, the question you probably are having is, well, why does it only have 2 arms? Because you don't want to rig 10 arms. So I figured this would be easier. There was a momentary lapse of judgment where I said, you know, I think I'll just give him like 4 to 8 arms and have you guys rig all of those this week. But then I realized that's probably not a good idea, and you probably would appreciate only having to do 2. So we're just going to do 2. What I'm going to be looking for in the rig for this week is that you guys will be using actually 3 ribbon spines in order to accommodate the 2 arms, 1 for each arm, and then 1 for the main mantle right here. We'll be having a root controller that goes around the middle of the body that you can use to move the character around. We will also have a couple of joints in the beak that will allow the mouth to open and close. And then we will also probably be having something, some sort of setup that will allow us to flap the little winglets on the side. Okay? And then all of this using the ribbon spine will actually make it quite stretchy and flexible. So this should be quite a bit of fun. Another thing is with the eyes, these guys are actually separate eyeballs. So we'll be able to do aim constraints to make the eyeballs rotatable inside the head. And since this is definitely not a robot, we will actually be doing weight painting this week as well. So we're kind of ratcheting up the difficulty on this, but it should be just fine for you guys. Okie doke? Yes? Yes. All right. So let's talk about the components of a ribbon spine. I want to see actually if I do have an example here. I think this one might be a finished one, but I can't remember. So let's download this and open it and see. Okay. Yeah, I think he's actually done. Yep, okay. So the ribbon spine allows us to get a fairly good amount of movement out of a character. It allows really nice deformations. So let me turn off the polygons. And we'll show. Okay, so this is actually the functional inside of a ribbon spine. So the reason why it's called a ribbon spine is because it literally has a ribbon running through it, and that's what actually controls the deformation of the character. It's kind of a double control scheme that's actually going on here. We are not going to be running joint chains in the way that we've run them last week. We're actually going to be running them kind of congruently with another system. So the main thing that's going to be moving the mesh is going to be these joints right here. So these little joints are actually attached to a ribbon, and then that ribbon, this little NURBS plane right here, is being controlled by controller joints, which are these guys right here. So there's 3 of these. And then those are in turn controlled by joints as well. The nice thing with this, the reason why we're using it, is because it controls a fall-off deformation of the ribbon. And so we don't have to have direct one-to-one control of a controller to a joint to affect the part in between two controllers. So like this area right here does not have direct control between, or does not have direct control from this controller or this one, but it's affected by both. And so you'll see that this ribbon will stretch, kind of like a rubber band between the two. Additionally, it'll also have fall-off twisting action, which we will not have if it's just a straight joint chain, because the joint chain is just going to rotate at the joint. But this, with a ribbon, it's going to have a deforming rotation. It's going to have a bit of a fall-off to it, like that. All right, so that's what we're kind of going with here. So yeah, any questions so far? Okay, cool. Let's go ahead and set this up. All right, let's go ahead and create some NURBS primitives. Go with a plane. And I'm going to go down to the inputs here for make NURB plane. I'm going to go ahead and give it a width, length. Let's change that to 10 for the length ratio. And we'll use this for like the first part of our body. We'll go and grab our geometry and put this on its own display layer. Now, I just brought this OBJ fresh into Maya so it doesn't have any history or deformations on it, but I will want to make sure and delete my history. And then also go into modify freeze transformations, just to be sure everything's deleted out and cleaned out. Okay? Yeah. Okay. All right, I'm just going to select those, select the body, go to mesh, combine. So probably what it was is there was extraneous faces from ZBrush, and so maybe it was like a separate poly group or something like that. And then I'm going to go to vertices, select all the vertices, let's do edit mesh, merge. I'm going to put my threshold down to like 0.00001. Tell it to merge. And then delete history again. And that should take care of it. Thank you for bringing that up. Okay, let's go ahead and name this. Squid body geo. squid body right eye. Squid body left eye. Okay, there we go. All right, so I'm going to go and take this nerves plane, put it down here. It's going to basically go from the tip of the mantle to basically like right where the head is. And then I'm going to go up to surfaces, and I need to tell the surface to actually rebuild. So I'm going to go from surfaces, click on rebuild, and I want it to go from number of spans V. I don't need 12. I'm going to do, let's do 6, and click rebuild. Surfaces is under modeling. So go to modeling tool set, up here to surfaces. And so what we're doing is we're basically telling the surface, the NURBS plane, to rebuild so that we have 1, 2, 3, 4, 5, 6 spans. So we have basically like 5 different edges that are going across here. And so that's going to be important because if we go back to our example, each one of these spans is going to be where a joint is going to be attached to. Okay?
And so, like, the spans can help with its flexibility?
Yeah, exactly. So the more spans you have, the more joints we can attach. So we can put one for every single span. You don't have to go with 6. You can go with really whatever number you want, but I would probably go with at least 4. Especially with the tentacles, you're going to be going with a lot more spans since they're so much longer and much more flexible. All right?
Is it fairly simple to go in after the fact if you realize you need another one?
Yeah, if you want to, you can just go back to surfaces, rebuild again, and then edit that number. So if we want like 8, let's click rebuild, and then now we have 8. Now, if you get too far to where we get to where we're doing the follicles and adding joints, that's going to be too far to start adding new spans because we're literally losing position here. Okay? So let's go do back to 6. I didn't know we were going to be getting rain today. I'm glad I brought my raincoat. All right, so we need to attach joints to the spans, but that can be kind of difficult. Like, how do you attach a joint to a piece of mesh? Any ideas? Parents? Who said parent? How would you parent a face to a joint to a face? Usually it's the other way around. And in fact, we don't even do parenting. We usually skin it. It's a trick question. You guys haven't been told this, so I just want to know if you have any ideas. Yeah, what do you got? You're talking about using the constraints? Okay. So we're going to be using something that kind of is constrained to the surface. And so in Maya, we have what's called follicles. And so follicles allow us to constrain objects to the surface of a mesh. Now follicles, what do you think of follicles when I say that? When I say that word?
Hair follicles.
Hair follicles. So Maya does hair. So we can actually set up a hair system to run on the surface of this mesh that then we can attach joints to. Okay? Which is kind of a weird workaround way of describing it, but that's what we're going to be doing. So if we go back to the example, this guy right here, you see these little red pins? That's actually what the joints are attached to. These are follicles. So in order to make those, we're going to go into Effects, and then I'm going to go to In Hair, create hair. And so we have some options here. We have our output is going to be NURBS curves, paint effects, and NURBS curves. I don't need the paint effects here since we're not really doing hair, unless you want to do like a hairy squid, but we're not, so I'm just going to do NURBS curves. We have a U count and a V count. We keep coming across this as U and V count. Kind of interesting. But what value do I probably need to put in the U and the V counts? 6 where? Where did I put 6 in before? V. Did I put anything in for the U? No. So I'm going to put in 6 here. Click on create hair. And so now we have these NURBS curves that kind of pop out. And actually, if I hit play, it's actually a simulation. So if you ever want to do hair, this is how you do hair. This is only 6 because this is what I needed for the rig. But you can add 100,000.
How did you get to the create hair option?
The what?
The create hair option.
It's under in hair and effects. Abdullah?
This is sort of an unrelated question. Is that being affected by like minus preset physics?
Yes.
Okay.
Yeah. Here, I'll display it in real time. It's fun to watch. So this is, you can use this for more than attaching joints to a mesh. You can use this for more than hair. This is something that you could use for creating rope. If you wanted to like attach chains or rope or whatever to a character, like say if they had like dangly bits, you could do a in-hair simulation to basically drive that.
Could we do
So.
it for like a cape too?
Mm-hmm. Well, actually, it would be probably more appropriate to do that with in-cloth, which would be the actual like cloth simulation, but it uses the nucleus system, which is what in-hair runs off of. So, yeah. All right, let's reset that. So I'm going to go into my outliner. I just need the follicles. I don't need the curves. I don't need the nucleus. So I'm going to go ahead and click on my nucleus here, delete it. Click on the output curves, delete that. Hair system, don't need that. I'm going to go ahead and click on hair system 1 follicles. I'm going to rename it squid mantle follicles. Make sure you name this, since you're doing 3 of these, it'd be a good idea to keep an idea of what, or to make sure we know which ones we're actually working with. And then under each one of these follicles, I'm going to go ahead and click on the curve name right here and delete. Okay? You with me? I deleted a whole bunch of stuff. So it said curve under each one of these NURBS. This was actually a, not really a constraint, but it's a connection between the actual NURBS curves that were in the outliner and then the follicle themselves. So I went ahead and just deleted that connection between them. I also deleted the output curves, and then I deleted the nucleus and the hair system. William, wake up. You gotta stay awake. Open them eyes. Okay. I really love the Kenny impersonation you're doing right now. The Kenny impersonation. Watch some South Park, boy. Okay, so let's go ahead and continue. So what I need to do is go ahead and attach joints to each one of these follicles. So I'm going to go ahead and grab, let's do side view, get back over to rigging, skeleton, create joints, create a joint, enter. I'm going to give it a name. Squid, mantle, follicle, joint. 1. All right, how many joints do you think I'm going to need? 6. So I already got 1, 2, 3, 4, 5, 6. I just went ahead and duplicated them. And I'm going to go ahead and basically nest parent these joints under their respective follicle. Okay? So with the number here, actually I want to go from the follicle that's closest to the center. That's going to be 1, 2, 3, 4, 5, and 6. So it should be 1, 2, 3, 4, 5, and 6. And then I'm just going to middle mouse drag each one of these under. Okay, just like that. So now they're nested under. All right, remember when I said we don't freeze transformations on joints? Okay, the reason why is because their XYZs are going to be basically the point of which their origins are, okay, for the origin of the world. So what that means is if I want to center each one of these on their respective origins, I need to zero them out. Now since I've put them, parenting them under each one of these follicles, if I zero out their transformations, that's actually going to snap them to their follicles. So I'm going to go and grab each one of these, each one of the joints, hit 0 and enter. So if I go and grab, let's say, the control vertices on one of these on the end of this ribbon, and then kind of twist it, you'll see that the follicles stay with the ribbon, and then the joints stay with the follicles. Okay? You guys with me? Okay, cool. It is, yeah, it is similar. They're sticking with the follicles because they're just nested under them. Exactly. So these will be our skinning joints. This is what we will use to actually skin the different parts of the mesh. Alrighty? Cool? Let's go ahead and create a couple control joints. So I'm going to do skeleton create joint. Actually do right here. So I'm going to go and put in a root joint right there. That's not any easier to see. Okay. And then we'll do a control joint here at the base of the ribbon. And so since we have 6, I can do one here, one there. Actually, we'll do one in the middle. So I'm going to do one at the base of the ribbon, one in the middle of the ribbon, and then one at the tip of the ribbon. Yes, sir. And so you'll see that each one of these is going to be snapped to their parent.
And are we gonna have one at the very top like we did with the robot on the missile?
No, this one, the tip is just going to be right here. So I'm going to go name this squid root joint. Squid mantle. Control joint 1. let's go ahead and just copy all that. Then we'll replace the 1 with a 2. And this one we'll do with tip. Okay. So these particular joints are going to be the ones that are going to actually control the ribbon for us. Okie doke. Okay. Let's go and do some beak joints. So I'm going to go ahead and create a beak base joint. I kind of like to do my rigging kind of modularly, so everything kind of has like a little attachment point. So like arms, for example, don't just go straight into the spine. They actually kind of branch off into a center joint. Hips don't go straight off the spine either. They just kind of go basically from a center groin joint. So there's like little areas that I can just detach entire limbs really easily for me. And so like for the beak, I'm going to actually do a joint right here. That's going to be my basically my main mouth joint. And then I'm going to do right here where the beak is going to actually move. And then I'm going to do a tip joint out here. So the beak is just going to be basically just pincers. That's all it is. It's kind of like the claw from the robot arm. There's no other movement to it. Unless you wanted it to like flap open in a weird way. But I mean, that's possible too, but I don't really want that. So I'm just going to keep it simple. And hit G again. So this is going to be where the the top beak moves. And then I'm going to go ahead and do another joint out here towards the tip. And so this one needs to be integrated into this other joint's right here, so like the beak base. So I'm going to select this hinge joint, the beak base joint, and then I'm just going to hit P. And that'll actually put both of the top and bottom beaks together under their parent joint. Okay? Cool. Cool. All right. Let's go and name that one. Squid beak base joint. I can't really decide if I want like him to have an underbite or an overbite, because I honestly I don't really know what the top and bottom of him is in this sculpt, so I really don't know. Maybe this will be like the top beak. He'll have like an underbite. Squid upper beak pivot joint. And then this will be squid upper beak tip joint. Squid lower beak pivot joint. Okay. I'm going to go ahead and tell this, I'm actually going to go and nest this under the root. So I'm going to grab the base right here, grab the root, hit P. So now when I grab my root joint, it highlights everything below it, which is going to be the mantle and everything above it, which is the beak. All right, you with me? So if we look at the outliner, this is what it looks like. We have a branch or a fork in the tree. So it's not just all simple parent-child, it's parent-child-child. So they're siblings. Any questions so far? Okay. All right, let's go back to this guy real quick. So let's go and add in some controllers. And we'll go ahead and get the controller joints actually attached to the spine. So what I'm going to do is go ahead and go into, let's see, actually my script editor. Because remember that Rig 101 wire controller script I had you guys download? So we're going to go ahead and use that. So open up your script editor, which is right down here. I'm going to go to File, Open Script. Go and find wherever your script is located. Click Open. Go to File, Source. Open the same script again. And what you can do if you want is go and create a new shelf under the shelf editor right here. And a lot of times what I'll do is I will collect scripts and kind of make a shelf that has all of these little scripts that I find, like from High-End 3D, CG Trader, or whatever. I'll find them and just kind of just put them up on their own little shelf. And I need to activate the script, so it's actually the command is how to use, run, and it says Rig 101 wire controller, semicolon. So I'm going to select this, middle mouse drag it up to the shelf, drop it, and then when I click, the script will run. Make sure you save all your shelves. And there you go. So, first script. So the reason why we're using this is because we can do more controller shapes than simply doing circles. Because as fun as those are, they're not terribly descriptive for what we're trying to do with our rig. Abdullah, do you have a question?
Hey, can you walk through from when you said how to use that on?
I'm just selecting the little command, middle mouse dragging it up to the shelf and letting go. And you'll see where the little M is right here. That's the actual script. If you want to, you can actually right click on it, click edit. And if you go to shelves, you can actually say what the icon label is going to be. And then save it, and you'll see it actually has a label now. Okay. All right. So let's do some shapes. We'll do some prisms, and I'm going to do a sphere. Okay, so you click on sphere, you got a little NURB sphere that pops up. And I'm going to go ahead and just kind of make it a little bit bigger. Snap it up to that controller. Actually, I think I want... We'll do this one. Yeah, we'll do a flat cross. Okay. I'm going to duplicate that a couple times. Okay. And snap it to each one of these control joints that we had set up. I'm also going to need to go ahead and make a need to make a root controller for him. So let's do I'm gonna do a cog. It's not giving me what I want. There we go. That's what I'm looking for. So this will be my root. And I'm choosing these shapes so it's easier for me to kind of denote what each one I'm supposed to do. So let's do, snap this guy to the root joint right there. And we're going to start naming these as we need to. Squid, root, con. Squid, mantle, con, or let's do mid con, squid, mantle, base, con, squid, mantle, tip, con. Okay. You should grab each one of these controllers, and I'm going to go to modify, freeze transformations, edit, delete by type, not all by type, and just do history. Make sure it looks how we want. Actually, this one I think is going to need to be a little bit bigger. Yeah, so we'll make sure it kind of circles around them nicely. Do modify, freeze transformations. And let's go ahead and finish up the ribbon spine since now we have the controllers. So what I want to do is go ahead and grab the, not the follicle joints, but let's grab the control joints. So let's do each one of these control joints right here. I'm going to shift select the ribbon, and then I'm going to go to skin, bind skin, selected joints, and leave it as classic linear and tell it to bind. So what that's doing is that is taking the joints, binding them to the mesh, this NURBS mesh right here. And so then whenever this joint moves, it's going to move the ribbon so we can actually work with it. Okay? So then what we need to do is take the controllers and basically constrain them to the control joints. You with me so far? Okay. So what can I do to constrain these controllers to their control joints? What would be an appropriate constraint? So I want to have a stretchability factor with the mantle, with basically the entire body. So I want to be able to move it around, rotate it. What constraint will be really good for that? Okay, what constraints allow me to move an object, to translate it? What are the constraints I can use? There's two. A point and parent, okay? What constraints allow me to rotate an object? There are three. Do you know? No, that's not a constraint. So parent, orient is one more. What's the last one that kind of controls rotations? Yes, aim. Okay. What overlaps in those two lists we just made? Parent. So we're going to be using a parent constraint because that controls rotations and translations. So I'm going to go ahead and grab my controller. Let's go ahead and grab our control joint, the one that actually works with it. And then I'm going to go ahead and go to constrain parent, maintain offsets, add. Ta-da! All right, let's go ahead and nest these two controllers underneath each other. So I'm going to grab child and parent, and make sure that these guys are all nice and situated. Okay, now we're going to go ahead and grab our controller again, go back to the proper control joint, and then we're going to go to constrain parent, and then we'll go down to here and we'll do constrain, let's do tip, this one right here, constrain and parent. Perfect. That's how you make a ribbon spine. So you'll just do that 2 more times for the tentacles. It's actually really easy once you get it done the first time. It's literally just the same setup. 2 more times with more joints. To an extent. You can duplicate the ribbon and move that up, but you're going to want to change settings. So you're going to want to change like the span numbers and everything, and that's going to cause you to go and change everything else. So yeah, it's honestly just as easy. Yeah. So you're not anchoring really those to anything other than the follicles that are going to attach to them, and then you have your control joints that'll attach to, they'll be skinned to the actual planes, and then those control joints are going to get plugged in to basically the root joint. So in the same way that this guy, this control joint is branching off of the root joint here, you're going to have the same thing going off here and here.
Same root joint, not making a new one.
Yeah, it's the same root joint. You're not making a new one. Okay?
And we would need to make controllers for those tentacles as well, right?
Mm-hmm. Oh yeah. Those tentacles are like the most fun thing on the mesh, so we better be able to control them. Okay. Why don't we go and take a break for a few minutes, and then we'll come back and I can start setting up some of the other stuff. Okay? So 10 minutes. Yes, I am. Thank you. Okay, so I'm just going to get the approximate length. We'll move it into position. Okay. For those of you curious, width actually doesn't really matter, since we're just putting one joint straight through. So it doesn't really matter how wide it is. Okay, so that should be fine. Okay, we'll do this as squid tentacle ribbon 1. So what do I need to do next? Does anyone want to take a wild guess? What was my next step? The what? The follicle thing. That's like the next step after this next one. You're like 2 steps ahead. Rebuild, exactly. So let's go under modeling, surfaces, rebuild. And so I had 6 spans before. Honestly, you know, that's fine for this. I probably want something like 12 for the tentacle. So we'll go and do 12 of these. All right. What's next?
Then you go to FX.
Okay, in hair, create hair. All right, what's my value is going to be? 12 where?
In the V, in the.
Okay. What do I want up here for output? NURBS curves? All right, NURBS curves. It's kind of a weird thing to say. All right, so I need to go and delete some stuff. What am I deleting?
The hair follicles.
Okay. Hair phodologicals. What else? Am I actually deleting the hair follicles though? So I need to delete these. Okay. Grab the hair system, grab the output curves, and delete. Also, I need to delete the nucleus. Delete that too. All right. Let me go ahead and duplicate the ribbon and just go and move it over so I have it ready to go. No, I have to recreate the follicles. So I'm going to go over to in hair, create, leave it at 12, and delete hair system, delete output nucleus.
Why do you have to redo that though?
Because it needs to, when you duplicate it, it's not going to. It's just going to duplicate the mesh. It's not going to duplicate the attached pieces. So since they're separate separate parts, we need to make sure and recreate them. A similar reason to why if you want to duplicate a rig, you can't actually just select a rig and hit Control D. You have to go in and actually like import it for a second time into a scene. Okay. So now we got follicles on there too, so that's good. All right. Okie dokie. So what do I need to do now? Mm-hmm. How many joints am I going to need? I need 4 joints?
No, I mean, we used 4 for the last one, so like.
We didn't even use 4 for the last one.
Oh, well, I mean the face, well, the head part.
Okay.
So like 8.
So we'll do. We don't actually need 8. We need more than 8. Squid.
Oh, that's right, because the tentacles are gonna be moving more, so.
Squid, tentacle, follicle, joint, genoid. Let's do joint. Okay, squid, tentacle, 1, joint, 1. Okay, so how many do I actually need? 12. But in total, I'm going to need 24. So let's do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I'm going to take all of these and actually let's go and attach them to their proper follicles. Okay. So which one? So it's that one. So it's going to be, okay, so tips here, base is here. So let's go and do this guy, this guy. Before I attach that one, I'm going to duplicate it. And then carry that one up there. Okay. So the reason why I duplicated it was so I could go back and change the name of this to tentacle 2, follicle joint 1. And then I'm going to duplicate this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here we go. So now it's follicle tentacle or squid tentacle 2, follicle joint 1 through 12. All right, so we'll go and open up this other system. Actually, no, we got this one. I need this one. Okay. Yes, okay, just want to make sure. Sometimes follicle positions can change. Like I've had them like out of order to where like the top one was like here, the bottom one was like up here. So I want to make sure they're all in the right order. We got a whole bunch of joints. I'm going to go ahead and zero out their translations, and they should snap to their positions. Cool?
Before you snapped them, they were all like piled up on it.
Yeah, they were just duplicated, 24 joints. All right, I'm going to go and save this before something terrible happens. Squidward rig. All right, what do I do next? I have the first set of joints in. What do I do after that? Say what? You said joints controllers? Switch those words. There we go. I'm not to controllers yet, but I can do my controller joints. Okay, so I'm going to have one at the base, let's see. So I have 12. So if I did every other one, that'll probably give me a pretty good. And then we'll do. Actually, we'll do these 3. So I can make. I feel like I kind of need like the tip of the tentacle to kind of like be able to like grab things and like close up. So we'll do those. Okay. All right, so we got all of that. Hit Control D and hit Shift P to unparent them from the parents that they were sitting in. And I'm going to go and take all of these and we're going to rename them. How can I rename all of these joints at once? Does anyone remember that? There's like a thing with a thing. Exactly. Thank you. So we're going to go to search and replace name right here. So what's the name I need to be searching for? So it's actually tentacle 1 and tentacle 2. That's not really the name I need to be searching for. The one I need to be looking for is going to be follicle joint. And then I'm going to replace that with control joint. So hopefully I didn't mess up my spelling for any of these. I think I just copied and pasted a lot of it, so it should be good. Replace. So now we switched from follicle joints to control joints. The only thing that's kind of weird is the numbers. But we can change that. So change the 13 to base. And we'll do 14. Where's the 14? Okay, so we'll just basically just grab the same ones. So that's 20 and 14. So I'm going to call this one lower do this one for mid. Actually, something might be a little bit easier to make these actually be able to be selectable and visible. If you just select all of these, go to radius, we can just make the radiuses bigger. So we can actually see like which ones are the follicle joints and which ones are the control joints. Just to make it easier on you guys. All right. Upper. I'm going to kind of label this one like wrist because it's kind of like where the wrist would be. Hand mid. Hand lower. hand tip. Hand tip. Hand mid. Hand lower. Wrist. Do upper. And this one is mid, lower. So I think we got everything. Okay, so we're good there. All right. So for each one of the control joints, let's go ahead and link them together. So I'm going to go and take child, parent, hit P, child, parent, P, child, parent, P, child, parent, P. And then just continue. Okay. All right, once I have the control joints, how do I get the control joints to control the ribbons? What do I do? How do they control the ribbon? What? Skin, exactly. So I'm going to go to skin, bind skin, selected joints, bind skin. And actually, I should have clicked on hierarchy since I had if you select like each one of the joints, it'll be fine, but I need to click on hierarchy since I only had the base joint selected. So, I don't believe it's gonna, yeah. So I need to rebind these. So just do skin. And actually, this would be a good opportunity to talk about what happens if you need to add a joint or modify something where you need to add a joint in or it wasn't added in under the initial skinning, because that will happen. So if you just try to go in and bind skin, it's going to give you an error message. It says selected geometry squid tentacle ribbon 2 is already connected to a skin cluster. So what do? Okay. Two options. One is you can click on the mesh, go to skin, William wake up, and then click on unbind skin, and then that will basically delete the skin cluster under the mesh. Okay, so it's not skinned to anything anymore. Or we can just go under skin, edit influences, add influence right here, and then click add. And so what that's going to do is that is going to put these joints into the skin or into the skin cluster that is attached under the history right here for that mesh. So if you ever need to add extra joints to a skin cluster mesh, this is how you do it. So it's under Edit Influences, Add. All right. Okay. And if we go ahead and test, it bends. Perfect. All right, I'm going to go and take the control joints right here. I'm going to go and add them to the root. And so now they will move along. Yeah, I just parented them. They'll move along with the rest of the skeleton. Okay? We can test that. Grab the root. And it'll move. Alrighty. I'm also going to go ahead and take this controller right here, select the root, nested under the root controller, and then this root controller, I'm going to go from root controller to root joint and constrain that with a parent. And so now the rig will move all with just the root, which is good. You with me? Okay. I know we're getting complicated today. Good thing we are recording. Okay. All right, let's go and start making some controllers for the controller joints. So these guys should get we can do triangles. Triangles are fun. All right. $90. Okay. Shrink it down. And so these are going to go for each one of the control joints. Just going to get rid of you for a second. So we got one right there. Okay. Control D. Trying to figure out which one's easier to see. Can you guys see like the joints and all that easily on the screen? Okay. Sometimes this stuff gets hard to see. All right, so we'll go and call this tentacle con let's do one. Tentacle 1 con 1. We will duplicate, move it up, snapping as we go, duplicate again. Okay. All right. Let's grab all of these. freeze transformations. Delete by type history. Again, we're just selecting just the delete by type, not delete all by type. For the love of God, don't hit delete all by type. And then we're going to go ahead and stack these, or nest these under each other. Okay. All right, I'm actually going to group these controllers together. The reason why is because I'm going to do a duplicate special on them, and I'm going to basically mirror them over to the other side. And what I want is for these guys to have the same orientations on either side, so that in theory I could like splay open the tentacles, like it's like going to attack something, just by using like one axis for a rotation. Okay? So with that group selected, I'm going to go to duplicate special, scale -1 on the X, and there we go. And now let's go ahead and grab all of these. And I'm going to go ahead and do search and replace names. Search for 1, replace with 2. And that will probably screw up this one right here, but let's fix it. Oh, cool. All right. Let's go ahead and take both of these groups. These are going to go nesting under the root controller right there. So now that they're nested properly, it will follow along. And then we need to go ahead and make each one of these joints follow with their respective controller. Okay? Okay. So let's go ahead and do that. So we're going to go and take parent, child for the control joint, and then we're going to do a parent constraint. And do it for every single one of these. And we'll test this real quick, make sure everything works before we do it to the other side. So it's kind of working, but it's doing something funky. Let's see what's going on here. Maybe I'm grabbing something I shouldn't be grabbing. Okay. 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 I think I might have been grabbing a joint that was causing it to rotate weirdly. Okay, I think we're good. Okie doke. Okay. Parent constraint. Good thing I'm not doing like a 75-foot long anaconda. This will take forever. Okey-doke. Right? Because they had, yeah, good thing I didn't give you guys like an octopus. Any questions so far? So really, I mean, this is just a duplication of what we just did for the mantle, so nothing too crazy here. Okay. Let's go ahead and do the mouth. So the mouth actually is going to be really easy. It's just going to be a controller, or actually two controllers that we can control. Or you could do a set driven key. Honestly, either way that would work. So however you want to do that, I'll leave it up to you. How do you want to do it? Set driven key? Okay. Yeah, it's literally the same mechanism. So we could do a set driven key. All right.
Like, are there situations where one is better than the other?
Set driven key is pretty well defined on what it's going to do. It's only going to do like those positions you key it for. But if you have like a couple controllers, like you can open it like super wide, you can like move the jaws from side to side. So you have more flexibility on that. So honestly for this, either way, I mean, I think the mouth's just going to be opening and closing. So I think it should be fine just to do a set driven key. So we can do that. All right. So let's do, grab this guy. Let's go and add in the attribute real quick. So I'm going to do add attribute on the root con. Let's do beak, open, close. Why every single time? All right. Minimum 0, maximum. Let's do 10. Add. Voila. All right. So we got the attribute in there, beak open close, and let's go to rigging, animation key, set driven key, set. What's my driver? Why is that the driver? Logically, why is it the driver? That's what moves it, right? That's the guy, that's the one giving the commands, right? Like you move to this position and the joints are like, okay, yes, sir. All right, so driven is going to be that, the controller. And then the joints are going to be drivers or drivens. They're going to be something, I don't know. All right, load driven. What axes are these going to be moving on? Rotate Z. So honestly, it's kind of hard to make an assumption of what our range needs to be without this being skinned, because the beak is going to need to be able to close fully and then open fully. So that's going to be kind of a hard thing to do without this actually being skinned yet. So let's kind of throw in a couple values, and if we need to, we can maybe go back in and like edit it or delete it later. So we'll go ahead and do the closed position. So I'm just going to move it to where I think it'll need to be. What I'm saying is basically I think I probably would do this after you do your skinning and weight painting and all that, just to be sure you have it correct. So I'm going to move this here, and then this will be rotate Z for both. Grab beak open and close, so at 0 it should be in a closed position. Click key. And then we will go ahead and grab that root con, set it to 10, and then we'll rotate this really wide, like honestly wider than it's going to need to go. Like it's really hungry. It's like my son at 1 a.m. when he wakes up after a long nap. All right, and key again. And then let's test. All right, it works. Yeah, that's what I'm talking about. All right, so until we get skinning done, I'm actually just going to artificially put these back to rotate Z value of 0. They will snap back to what they need to be as soon as I touch the beak open and close. But for skinning purposes, I want these to be back in their original position. So I'm just going to go and put in 0 there. Okay? So otherwise, I don't want the joints to be skinned with a weird rotation on them, because then it might like snap them open in a way we don't really want it to or expect it to. All right, so that takes care of that. Let's do eyeballs. Yay, eyeballs. So for these, what we can do is put in a joint for each eye. Just like that. And it needs to be in the exact center of the eyeball. Now that's going to be kind of hard to do, but we need to do it so that when the eyeball rotates, it does not center the pivot. So when it rotates, it doesn't cut through the mesh weirdly, okay? So let me actually, since this actually is not a perfect sphere, I'm going to actually need to move this forward just a little bit. That feels better. Yeah, I think that's pretty good. If you look at it from the side, like that looks like if you just completed the rest of the sphere, that looks like that's pretty close to where the center would be. So I'm happy with that. So the thing is that we need the joint to be in that pivot point. It needs to match that exact same pivot point. So one way that we can do that is we can actually do a parent constraint, but turn off maintain offsets. Okay? Remember how we were turning that on before? So if we turn that off, it will allow us to basically pop the joint into that position. Now we're going to be doing this in a reverse order, where before we were grabbing the parent, which would be like the controller, and then the joint. This time we're going to be doing basically mesh and then joint. Okay? And we're just doing this just for positional. So I'm going to grab this. I'm going to go and turn that off real quick and so let's take this eyeball and then actually grab the joint, constrain, and actually I don't even need a parent. I can just do a point. Make sure maintain offset is turned off, because I really just need the position. And then click add, and then you'll see that the joint just moved a little bit. Okay? So if I go to where the joint is right here, let's go and rename it. Eyeball center joint. Give it like a name of like left, and I need to actually delete the point constraint so it's not actually adhered to the eyeball anymore. So I'm going to go ahead and grab that point constraint that's under the eyeball joint, delete it, and so that leaves us with the new position. Okay, I'm going to hit Control D, move this forward, and then parent this joint under the center eyeball joint. And this one's going to be called tip joint. And this is purely here to show what direction the eyeball is pointing in, because otherwise, as you see as I'm rotating the joint, the base joint that I've selected doesn't actually show rotation on it. Like, you can't visibly see it rotating, but with the fact that it has a child, the child will orbit it. Okay, so that's what I'm wanting. All right, let's go ahead and take this joint, group it, modify. I'm sorry, not modify, edit, duplicate special. And as long as the mesh is centered, it should pop over to the other eyeball just fine. All right. Next thing I'm going to do is go ahead and create a new joint. This is going to be where both of the eyeballs are actually going to be attached to. So I'm going to go to Skeleton, Create Joints. And this is just going to be just a center joint. Didn't mean for it to do that. Here, we'll just do this. There we go, that's where I want it. Okay, we'll just move it down just a hair. Okay. Eye center. There we go. All right, and then make sure we do change the name on here from left to right. Take both these joints, grab this center joint, hit P to parent, and then where does this guy go?
To the root.
Yep. Just grab the root and parent. All right. So the eyeballs need to follow the eye joints. So I'm just going to go in and basically just grab the eyeball mesh, the eyeball joints, go to skin, bind skin. Actually, no, this needs to be skin, bind skin, selected joints, not joint hierarchy. So we just want one joint that we're going to be binding this to. There we go. So now, when we rotate, the eyeball will orbit or rotate with the rest of the, or with the center joint. Got it? Okay. All right, let's go and create a couple controllers. Do a circle. Squid look at left and duplicate that one, move it over, right. We'll move both of these out. Let's do maybe like basically just right out to here. I don't want it out too far, but I want it out far enough to where I can get some decent motion. So move it out to both to these positions. And then we're going to freeze transformations, delete history on these controllers. I'm going to go ahead and actually group both of these controllers together. squid look at con group, so that these are just one group that are together, and then I'm going to put that under the root con. Okay. So what I want to do, if I want to be able to move this controller and have the eyeball track it, what's that constraint going to be? Aim? Okay. So what joint am I going to be clicking on to do the constraint?
The one inside the eye?
Yes. So let's go and do parent. And then the child is going to be the joint, constrain, aim. Make sure maintain offset's turned on. Click add. And now eyeball is following the controller. Make sure when you're selecting this, you are grabbing the eyeball, the joint, not the actual mesh. If you end up doing, like, say, a constraint with a mesh to something that already has like a skin cluster on it, towards actually skin to a joint, it's going to create what we call double transformations. So that when you rotate it or move it, it's going to move twice whatever value you give it. Because what's happening is getting two incoming connections, one from one parent, one from the other. And so it's just doing it 2 times. So just be very careful when you're selecting things. If that happens, you probably just need to go in, delete whatever constraint was attached to it, or deskin it to where it's not connected to one or the other. Okay? It's going to happen. At least 3 of you will have it happen. Who will the 3 be? It's not a huge problem. It's just it's an easy fix. It's going to happen. It happens to everyone. Okay. All right. Let's go and turn on that body again. Check it out. See how this works. Perfect.
And then, say if you have a character that has 2 eyes that move independently from one another, you would just not group the controllers together?
No, I'm grouping them together so that they're easier to find in the outliner. If you have, now these eyes actually won't move together because they're on opposite sides of the head. So they're going to be kind of like chameleons. They're going to move like wherever they're looking, wherever they need to look. But like if it's a human, what you would do is you would actually have something that kind of looks like a pair of glasses that sits out like in front of the character's face, and then there'll be 2 maybe smaller controllers under each one of these. And so what you can do is grab the look at control, which would be the one that actually is the parent, the nested parent of both of these smaller controllers, and that will move both of them together. And then you can grab each one of the ones in the center and move them independently. So if you want like somebody that has like cross eyes or something like that, you can do that. All right. Any questions so far? Yeah.
Do you want us to put limiters on the eyes?
You know, it's up to you if you want to. With an organic creature, especially with something like this, it's not going to have a lot of limitations in the way it can move. So it's not going to be, if you do limiters, really that'd be something more on the joint. So instead of going into the controller, you would click on the joint and do limitations on that for rotations. Yeah. So, but usually with organics, I usually try to give them like as much, I usually don't try to limit them because there's not really that much of a limit to them. All right. Let's do, that's actually kind of bright in here. I'm trying to clean up a little bit some of this stuff. Like, I don't think I need some of this. So I'm gonna get rid of that group right there. We can take all of this. What is this right here? Oh yeah. This is one of my, okay. Okay, he did not get attached where he needs to be. Where are all of you guys? Oh, they're under here. Okay. Oh, maybe I should just have an extra one. Do I have an extra one? Yeah, I think I do. Yeah, okay, we're good. I just had an extra controller in here and it looked like it was also skinned to the, or actually it looked like it had a separate parent constraint to the same joint. And so I just want to make sure I got everything correct. All right, let's kind of clean this up a little bit because our next big thing honestly is just going to be skinning everything together. So I'm going to make sure we got it. So grab that, grab that, grab that. This is all going to be our squid mesh group. All of the extra bits, follicles, joints, we'll do the joints here. Okay, squid joints group. Squid con group. And then all of this here, I'm going to put under, let's put it under another group, call it ribbon spine group. And then I'm going to drop that under the, actually no, I'm going to leave it as like a fourth group since it's kind of, sometimes in my rigs I'll have like an arbitrary group that I'll just kind of put like other stuff into that doesn't really fit. And so this would be just like rigging remnants type stuff that I need to keep, but I don't really have a place to put it. So I'm going to group that again. Squid, char, group. All right. Make sure the geometry is under the geometry group. Con group, we'll go and make our own little group for that. I'm sorry, not group, layer. That's what I need. And then joints. Okay. All right, so now we are nice and organized. And delete any layers I don't need. Okay, so let's go ahead and skin the squid.
For our exercise, you want us to do those little fins too, right?
The little what?
The fins on the side of the mantle, like
Yeah, we'll get to it.
Okay.
We'll get to that. I probably will add that on like next class because we're going to be working on actual skinning next class because yeah, it'll take a little bit of time. Actually, let me go ahead and hide a couple things. So the ribbon spine stuff that like we don't necessarily need, well, we actually will need it because we'll need the joints, but we're going to be able to get rid of them like really quickly. So we're actually going to need to grab our skinning joints, which will be the joints under the follicles, and then the beak. We've already done the eyes, and then we're going to have a root joint. So we're actually not going to be grabbing all the joints to skin this to. We're going to be just going to be grabbing like certain joints that actually are going to be skinned. So there are extra joints in here we do not want to skin. Okay, it's just going to add extra work for you. Okay, that's the reason why we're not doing everything. So let's just go and grab the ones that we need. So I'm going to do follicle joints for the mantle. And then we'll do the tentacle. Keep in mind, I am not grabbing the control joints. So do not skin those. That'll actually will give you like double transformations, since those are going in and actually controlling the ribbon spine itself. So it'll actually create double issues for you, so don't do that. All right, and then open up each one of these. Okay. So make sure that is all selected, and then let's go under the joints. So I'm going to go and grab my root joint, and then I'm going to do the beak, which is going to be the beak pivot right here, and then the beak tip. So all four of those. No control joints. I don't need the eye joints because those are already, well, maybe actually, yeah. I think I'm going to actually grab the couple of the eye joints. And the reason why is because when you move your eyes, like your lids actually kind of follow along with it. So there's like a little bit of movement that's kind of in there. So we might want to skin just a little bit of like the area around here to follow those eyeballs, just to make it look a little bit more natural. So we'll actually grab those center joints. Okay. All right, and I think that should be it. Okay, that's a lot. All right, let's go to skin, bind skin. And we're gonna need to go and select our mesh. And so we have bind to selected joints, bind method. I'm actually going to change the bind method from closest distance to geodesic voxel. And then skinning method, I'm going to change to dual quaternion. The reason why is because the math between these different methods actually maintains volume a lot better. So like when we're going to be bending the tentacles or the mantle, the dual quaternion is really, really good for that. Okay, so we're just switching it up. So I'm going to go over to bind skin, and it's going to think, and that's it. So let's test it. Let's turn off our joints. I'm going to grab the ribbon spine, hit Control H on there so it actually hides it. I'm going to go to the geometry and lock it. And I just want to grab the controllers and kind of play around with them for real quick. ahead. It's always kind of a hold your breath moment when you grab the root for the first time and then like move the whole rig because you're like afraid something's just gonna like shear off. So it looks like it's working. We'll see how bad the deformation is for our beak open and close. Oh, it's terrible. Look at that.
Oh, man.
So we need to do some weight painting for that. But it's there, so it's working kind of. All right. I'm going to stop there. We'll do weight painting next class. I think we covered enough, right? Kate's face
I'm ready.
is melting. I just see it. She's like, oh God. All right, let me go and turn this video off.